We are your home theater and AV questions answered. This is AVRant. Want your home theater or AV question answered by Tom and Rob? Send it to question@avrant.com. Welcome to the special edition of AVRant. I'm here with, right now, one person, which is...
Rob H. Yes, yep. This is AVRant. Normally, we are your home theater and AV questions answered, but for this special episode, this interview episode, it'll be our questions answered by someone else.
That's right. This is all a secret. You guys had no idea, and gals, had no idea this was coming.
Right.
We have set up it, and by we, let's be very, very clear here. I had nothing to do with it whatsoever.
We have some thank yous to give, but I'll get to that in a moment.
We do have some thank yous to give, but I was in the periphery. Let's call it a managerial role.
Okay.
I think that would be the kindest way to say this. Mostly, I was like, I just said. Somebody asked me if I wanted to do a thing, and I was like, yeah, I don't care. And that was my involvement. That's what I did.
We got a little bit of scheduling done. Yeah.
We did. I just, and of course, those of you that remember, this happened, of course, right at the tail end of me having COVID.
That is true. Yeah, you'll see some differences. You got us, our regular looking intro here, our regular sounding intro here, but the interview itself, well, you're not going to see Tom because he wasn't in video form during that. I had hair from a week ago that was shorter and a different shirt, and then different microphones around and stuff like that. So yeah,
I was still in quarantine at the time because I had COVID. I didn't get out for another couple of days, and actually, I'll be honest with you, the brain fog during that interview was actually better than the brain fog I'm having right now.
which might explain why we haven't even said just yet all this time into this introduction.
Yes.
Well, what is this?
Well,
what is
you've
this
read
interview
the title of the podcast.
Maybe you have.
So this is an interview with Dave Pedigo from Trinnov.
That's right.
Those of you that know who Trinnov is, you're very excited. Those of you who don't, think of Trinnov as... If you are super serious about surround sound,
yes,
these are your guys. These
immersive
are like
audio in particular.
Yeah, these are the products that you are like, I don't want just a regular AV receiver. I want the best. And arguably, Trinnov is the best. So,
well, I mean, what we can say for sure is if you've ever looked at the Dolby Atmos for home installations diagram and said, okay, this system can technically go up to 34 speakers plus a dedicated low-frequency effects channel. That's 35 channels of information. I've never seen a 35-channel AV receiver. It's like, well, Trinnov are the company for getting their altitude processors that are capable of that full channel count and then some, and they are putting that and then some to use, which is very much the topic of the interview that we're mostly discussing today.
Right. So our interview with Dave went for a little over an hour. So
more than just a little, yeah. We were verging on the hour and 45 minutes there.
So you're gonna have a full-fledged extra episode this week of just that interview with Dave, and we're mostly talking about waveforming.
Correct.
So as a quick introduction before you get into it, we will talk about it with him and he will explain
very
it in more
much
detail.
So, yes.
But we talked about waveforming a while back in our podcast, and basically the idea is you have a bunch of subwoofers at the front, a bunch of subwoofers at the back, and they work together in order to create more even bass throughout your entire room, but it's not the normal way that we think of it. Normally, when we talk about placing subwoofers, it's all about kind of passively getting this done. And you put them in the right spot, and then you kind of cross your fingers and go, I hope it works. And it usually does, to a certain extent. This is more active. There's the kind of emitters at the front. Very
active. Yeah.
and at the back, they're I don't want to call them catchers, but they're essentially
they refer to them as absorbers, active bass sound wave control, hence the name waveforming. But then they go beyond that to also using the drivers that are at the front of the room, referred to as emitters, but also as absorbers of their own, because those sound waves are coming back from the back of the room, as well as reflections off the side walls and ceiling and floor and that. So all the drivers are acting as active bass wave absorbers as well. So yeah, it's a very sophisticated, complex system, which we discuss in detail.
So if you're listening to this on the day it's released, waveforming is officially announced at the same moment as we're releasing this
officially
podcast.
Available to the public. And there's I won't say it right here in the introduction, but a very pleasant surprise about this public availability of Trinnov. If you're used to the normal upgrade path of features like this, you're going to be very pleasantly surprised.
Drac. Sorry.
We never brought that name up during the interview. Dave never heard those names come out of our lips.
I think I might have said it once.
Maybe so.
I probably did. I'll be honest with you. So we're going to get straight into this interview. You guys can enjoy that. If you want to get your questions answered on this podcast about waveforming, about Trinnov, about anything home theater, and really anything else, just send them to question@avrant.com. We're going to leave off the rest of that stuff that we normally talk about, but that's the number one way that you can get in touch with us. At the end of this podcast, you will also hear Dave give some contact information, and we will talk a little bit about how to contact Trinnov with questions or concerns or even feedback as to how waveforming is working in your room.
That's right.
So let's get right into the interview. Welcome, everybody. This is our interview with Dave Pedigo, who is with Trinnov Audio. We've already did the introduction before this. We haven't done it yet, but we will do it. So, Dave, we're going to jump directly into the questions with you. So let's start with you. Let's introduce yourself and tell us a little bit about your position at Trinnov Audio.
Yeah, so I kind of serve two roles at Trinnov. So I am the Chief Operating Officer. So I kind of oversee the day-to-day operations for the U.S. distribution side of the company. And then I am the global director of training as well. So I also develop and run the training program. Right now, it's specifically for the high-end market. And I've been in this industry for a very long time. Worked at Cedia for a long time. Worked at Orlex. So I've been doing this since dinosaurs walked the earth.
I love it when the C-suite executives are also into it, hands-on. I mean, director of training, that means you know this stuff inside and out, not just a strict business person. So I love that. We're all home theater geeks around here for sure.
Absolutely. Huge nerd. When I worked at Cedia, it was just what did you do? I did a lot of things. So my just thing was I'm the nerd. That's what I do.
So tell us a little bit about Trinnov. We've all, of course, heard about it. Most of our listeners are very familiar with some of your products. But for those that are just coming here because they want to know more about the particular product that we're going to be talking about, let's start off with a little history or a little background about Trinnov.
Yeah, actually, it's great to do that today because I just taught a level 1 class. So I already went through the history earlier today. It's fresh in my mind. So Trinnov is at this point over 20 years old, and it was founded by 3 members who were basically met in engineering school in France, and all incredibly bright people. And so they, in the late 1990s, decided that they wanted to form a company which they could make a difference and solve a problem. And they figured out that how sound actually interacted in a room really changes. So I have a picture of Arno Laborie from many years ago, actually. So this is one I will send. And his grandma, how cool is this? So the 3 founders, Sebastian, Remy, and Arno, Arno's grandmother for 5 years let them build their company in her apartment in Paris. And Arno, this picture is of a young Arno, and they've got a whole bunch of identical speakers. And they realized that even though you had the same speaker, it sounded very different in different parts of the room. Mm-hmm. And so that was kind of an elevation. So not just same difference horizontally, but vertically as well. So they decided they really wanted to figure out spatial audio. So, we talked about, spatial audio and Atmos in home, those kind of things coming out in, 2015, et cetera. But these guys have been working on it since 2000. And so they really got their start in the early 2000s in pro audio. They really didn't get into the high-end market until the Altitude 32, which came out in 2015. It was announced in 14 and came out in 15, which is funny because I'm old enough to remember when HDMI came out with the 1.4 spec, and they're like, oh, and 32 channels of audio. And we're like, who in God's name needs 32 channels of audio in their house? And, it really turned out lots of reasons. But so that's really kind of who Trinnov is. But what encapsulates Trinnov is that we are a research company first and foremost. If you were to look at who we are as a company, well over half of our employees are in the research and development side of the company. And we are really continued on focusing on understanding how sound interacts in a room and then using signal processing to actually overcome those challenges. So if you actually look at like Arno Laborie, what his engineering is, his engineering and his degrees, multiple degrees, focus on signal processing. So we've got PhDs and, mathematicians and acousticians and all that. Their goal is to continue to press the boundaries of our human understanding of sound and then figure out the best ways to reproduce it. They're not a money first company, which may sound counterintuitive when you look at, kind of the price point for what a Trinnov is. And the reason why we do it is because the price is because we put expensive stuff in there, and we also use incredible amounts of computing power. So if you look at how we design a system, we actually have a PC that's built inside the Altitude because we are using so much complex math, and it's all based off of research. So, to take a short question and make it very long, which I do a lot, is we are a French company, and we are a research focused, really trying to solve the boundaries. And that, you see when waveforming comes out, we're not charging for a waveforming upgrade. We're not charging for, we don't charge for software upgrades. So a year ago, we came out with 4.3.1, and we figured out a way to capture the noise floor and called adaptive preemphasis, not to get too nerdy, but that captured the noise floor, and it changed how we did our calibration process. And so we're continuing to push the envelope, and it's because the founders really want to push us as a research first and performance first company. So that's who we are.
Going right back to what you said, sort of started the whole thing. That's one of our favorite myths to talk about on AVRant, is the idea of, if I buy 3 identical speakers and I put them as my left, center, and right, I'm guaranteed to have a 100% flawless timbre match, no matter what else is going on. We're like, not necessarily. That difference in placement, that center can still sound different, even though it's an identical speaker.
Yeah. I mean, I spent a lot of time in my life in acoustics, and I ran Orlex Acoustics for about 3 years. And, it's very funny. Even us, we will say that we still think that the best performance is to treat the room as well. And that is because once the sound leaves the cone, how it interacts in the room is everything else. So no, you cannot get the same timbre match with 3 speakers. It guarantee it with 3 speakers in the same room.
So it's a tradition around here for guests to let us know about their own home theater setups. There's no better bona fides for our audience than that. Tell us a little bit about your room. I know it's kind of under construction right now, but you're clearly sitting in a nice space as we speak.
Okay. Well, I will talk about this, then I'll tell you my room. So this is the Trinnov headquarters. So I live in Indianapolis, and then I travel to Connecticut every other week or so. This is our headquarters. This is our theater. So here we are running a 22.8.9 system.
Oh, okay. Oh, you got a voice of God in there for Oro. Is that what's going on?
Well, so we do have the voice of God, 6 overheads, and then a couple extra height channels. We've got our wide channels. We're using the LCRs. Oh, they're just a meager Ascendo Black Swans.
Okay. A little bit of output capability.
Yeah. What the funny thing is when we're teaching when I'm teaching the class, because we have to do the crossovers, the horns are 117 dB sensitive.
Okay.
So we have to do the crossovers very, very carefully. So we've got a 32-inch Ascendo infrasonic, and then in this room, which is a larger room, we have 4 21-inch Ascendo subs in the front and 4 21-inch Ascendo subs in the back. And so the fronts are the emitters, which we'll be talking about, and the rears are the absorbers. We got a Barco Freya projector and a Seymour Screen Excellence screen. It's got the vertical masking on it, which is fantastic. And then we're running a Kaleidoscape, Strato, and then Mad VR.
Okay.
So it's it is whole hog. So now let's talk about my killer space that I have. Now I sold my house. I had a nice theater before. I had a nice screen, like 14-foot wide, 235 screen. But my wife wanted property instead of anything else. And now I live in like a 1960s piece of crap, but I've got 2 acres. So there's that.
Okay.
So I have a 55-inch OLED, which is my pride and joy. I am different than most people. I do not need a gigantic image. I am a sit 2/3 of the way back kind of guy. I do have on loan a altitude 16 and a amplitude 16, and I run, because my room right now is 10 feet by 12 feet, and we'll talk about this later, because I'm running waveforming in this 10 foot by 12 foot with not even 8 foot tall ceilings. But I have 2 acres.
I mean, you could have an anechoic theater, you just have to do it outside.
Just knock down all the walls. It's just with stick framing. You have to worry about the reflections.
Exactly. So I have 3 JBL speakers for LCR, and then I don't even have rear surround at this point. And then I have 4 subs, and I have 2 JBL subs, and I have 2 clip subs, because I wanted to test ported and non-ported. See how that works, and basically take subs that aren't the same. And then I do have 2 KEF bookshelf speakers as well that I do some like comparison testing and listening to. So nothing extravagant. I mean, obviously the Trinnov stuff is the nicest, but
surprise.
I don't own that. So, the nice thing is that Trinnov has basically enslaved me to work for them forever, because if I leave, I have to give up my altitude and my amplitude. So
can I tell you what I absolutely love? I mean, here you are, COO of Trinnov, C-suite executive, and this is a common thing that happens to us when we interview people who are right up there at the tops of companies.
The CEO of SBS, I mean, his home theater, nobody's got a good home theater if they're too busy working to have a good home theater.
Todd Welty from Harman came on. He's like, I'm using a sound bar at the moment. I love that.
Sound bar.
Everybody is like, it's living in the real world situations, even for the folks who are right at the top of the companies for all the things that people are aspiring to purchase.
Well, I will say, kill me now if I'm going to use a sound bar. Don't get me wrong. I like sound bars for a specific purpose, but I want to have proper distance between my left and right speaker. I want to have enough room. But in my old house, when I sold it, I had an 11.5 foot wide Stewart film screen, 235. Absolutely loved it. Had triad loudspeakers. It was absolutely beautiful. But now I live in a tin cup. So until I can build an addition, and that I also put 2 girls through college. So
there you go.
A wedding. I just paid for a wedding. So but I have ambitions of a real theater because I have a small house, but it has a detached garage, and
There
that
you
will
There you
go.
become my
go.
theater.
There it is.
Yeah, yeah, yeah.
Yeah,
That's
you are.
that's in
We've
my
got a
plans.
listener who's got a detached garage that he's
Yep.
trying to build a theater above that he wants to paint it with that Vanta black paint so it'll be absolutely
Oh,
pitch black in there. So
well,
we've been talking him
I,
off of a bunch of ledges, to be honest with you.
I mean, there's contrast ratio, and then there's that.
Right.
Yes.
So
It's a
yeah,
little different.
And just before
yeah.
we move on from this section, I mean, I think I know the answer to this, but that headquarters theater that you're sitting in right now at Trinnov, I'm assuming it can hit full cinema reference volume.
Oh, oh, okay. Oh, okay. So let me explain to you what we did before we did the grand opening. So it's Peter Aylett from Officina Acustica. The gorgeousness that we have in this room is from Officina Acustica, and Jeffrey Heinzel from Ascendo, and I think Adam Pels wasn't here yet, but we have a whole bunch of us here, and we decide to run the wormhole scene from Interstellar.
Okay.
And this is with the 32-inch infrasonic, and we are running it at 12 dB over reference.
Oh, all right.
And the skin on my face was vibrating. It was, honestly, and I'm not kidding, it was the most immersive experience I ever had in my life. And to Peter Aylett's credit, or to my self-deprecation, he's like, to be fair, you have a lot of skin there. So, but it was, yeah. But
no,
now
that was everybody. It doesn't matter.
It was jiggling the fluid in your eyes. Don't worry.
Oh my God! I mean, you're talking about wavelengths that could be down, way past 100 feet, and so we actually could not shelve things off the shelves way outside the building.
Yeah.
So, sure. Yeah. We can do way over reference level, no problem.
All right.
So
but it's not comfortable. I'm not a.
Yeah. Right. Yeah.
I'm not a.
Do not do that for a prolonged
say,
period of time. You will damage something in yourself. Yeah.
That's
right.
I'm sure OSHA has something to say about that.
Right.
So,
yeah, for sure.
Trinnov waveforming, which of course is the main topic of our discussion today. Let's just let you start off on it. So this is the new big thing that you guys we've kind of touched on it, I believe, in the podcast in the past. There's been some hints about it, but before we deep dive into it, let's just get it like kind of an overview. What is this? What is the technology? So
waveforming. So we announced it a couple years ago. It's been about 2 years ago. And so now it's finally publicly available. And over the last 2 years, we have been doing them in very select studios or theaters just to make sure that we got it right. So what waveforming is our approach to handling the most complex and difficult challenges inside the room, which is the lowest of the frequencies. So let's say roughly 100 hertz and below, 150 hertz and below. We can guarantee roughly around 100 hertz and below at this point. We'll continue on in our understanding. And what it is it is an active acoustics approach to handling the low frequencies in the room, particularly, I would say, in kind of two fashions. One is three really. So one is seat-to-seat consistency.
Okay. So
it is really, really difficult to get seat-to-seat consistency. So if you look at the CEDIA RP22 document, their level 4, which is the highest level for home theater, in the base frequencies, they say that you should have no more than 2 decibels of variance at the primary listening position and 1 adjacent seat.
Okay.
And we're able to, when we're doing our highest level performance, we're able to get 1 to 2 decibels of variance across every single seat in the room. So we're looking at very consistent bass response across all seats. The Next thing is it's eliminating room modes. And we're able to eliminate room modes by using, in the highest levels, an array of speakers in the front. And that's kind of where the term waveforming comes from, is we are creating what's called a planar wave. And so we have a planar wave. So we have basically shaped or created almost a square wave that is coming forward. And because it is transmitting in that way, then we're able to use the subwoofers in the rear to absorb that sound. So it's not just how we are laying it out, but it's the timing and the synchronization to create a pattern. We can actually steer, if we found that we needed to, the algorithm can actually steer the bass in a particular direction or another. So basically we have an impulse coming this way, and then we're absorbing it. So we don't have room modes, or we significantly reduce them. In this room, as an example, there is a 50 hertz room mode. And so we do a demo where we're like, okay, well, we're going to play 50 hertz and we're just going to play it without waveforming. And there is in spots between a 20 and 30 dB variance in sound pressure, which is what happens, or there's no pressure at all in a room mode. We most of us have experienced it. And we turn waveforming in, and we walk you around, and we say, use a dB meter, and it is 1 decibel of variance across any spot in the room. It's nuts. It's bananas. It's like it shouldn't work, but it does. So the second part of us is eliminating room modes. And then the third part is kind of what goes hand in hand, which is then significantly reducing the decay time of the room, so that that bass is coming in, it's punching you, and then it's going out. I was at ISE a couple years ago, just when we first had announced it. And I had to, first of all, I watched the John Wick 3 clip 50 times, and it never got old. It never got old. But I would just sit and I would actually watch people's expression to just see the smile on their face. And I remember afterwards asking a lady, what do you think? And she's like, I felt like I was being shot. And I was like, yes. I mean,
when the signal says stop, the sound stops on a dime, right? That's the idea there.
Yeah, it does. I mean, we're talking about 10 to 20 milliseconds at the lowest of frequencies. You know, basically the concept of watching a movie is that suspension of disbelief. So, we want to watch a movie as the director intended. And so when we are watching a scene where there is an explosion out in the middle of a field, you are not getting reverb. It is that quick explosion, boom, and it's done. And the problem is in small rooms, because small room acoustics in many ways is harder than large room acoustics, that sound is reverbing, and that's not how that is supposed to sound. So waveforming is taking care of that as well. And we can show you images if you want, where we show a wavelet, and you'll see the wavelet of the pressure. So it's going to be frequency, time, and intensity. The color is intensity, and you can see the before and after of what happens when when you're going through and
in
doing
that time domain.
In that time domain, I can actually, I should be able to
do a screen share. Sure.
I can do a screen share, so I will present for just a second. Screen share here. And share screen. Okay. And I am just going to do my entire screen, so hopefully nothing bad pops up. Okay. So if we look here, if I go into my software, I can pull up our graphs, our waveforming graphs. And this is really what's going on. So we have a couple of graphs. So if I look at the before, this is what the amplitude problems are going on with these subwoofers.
Now, different seating or different measurement locations that we're looking at.
These are all measurement locations. And you can see that between those positions, it's -10 to almost +10. So we're talking about a 20 dB of difference, which is massive. That is 4 times as loud. So when we go to after, if you look at this, then you can see what we would call MSD, the mean spatial deviation between all the measurements here across the frequency. But then the other thing we can do, I'm going to go back to before, and sorry, there's a little latency there.
No worries.
And then this is the wavelet that we're talking about, and you can see. So this is the frequency, and this is the amount of time. So we're talking about it taking let's see here, 200 milliseconds for this to decay.
Okay.
And then this is so you can see that the amount of pressure is not linear based off of time and based off of frequency. And then this is the after effects. It'll take a second for it to repopulate.
Okay.
And you can see how linear it is.
Right.
And then also we get the ability to then look at the metrics. Oh, sorry. You will ultimately be able to see the metrics. I can probably send you an image of that later. I haven't updated the software because this is I have to redo the software here.
Sure.
But you can ultimately see the metrics. So we will tell you where your layout was before and after waveforming as in regards to RP22.
So some of what you said there probably addresses the next question, but Tom and I, we talk about using multiple subwoofers in rooms all the time. Not in this new Trinnov waveforming fashion, but we talk all the time about that seat-to-seat variation that you get, trying to produce more uniform bass. If you have more uniform bass, you can more effectively equalize it, all those types of things. But we completely understand that, just intuitively speaking, someone might say, hey, I've heard of Dolby Digital 5.1. And, so 5 speakers and a 0.1, and in a lot of people's minds, that 0.1 is a subwoofer, and it's 0.1, so it's one subwoofer. And just intuitively speaking, we can never blame somebody who says, okay, look, most of the time, I'm watching my movies in my theater alone, and if I have my significant other with me in here, they don't care about it as much as I do. So it's like, for the person who it's like that primary seat really is the one that matters. What is waveforming giving to them? Like you kind of already mentioned it with that third one. It's that time domain response is going to be whether you're a single individual or caring about every seat. But is there more to it for that single listener where waveforming is really going to deliver something for them?
Oh, sure, because you can see the intensity across the frequency band. You can see that line that goes all the way through. So I would say that it does it in a couple ways. One is that it is the equal intensity. The other thing is we don't think about wavelength enough. For those of us who really care about acoustics. And so when we're looking at, wavelength is a distance from the time that one 360-degree cycle is created. So an area of high pressure, low pressure, and back to zero.
Or a full out and all the way in and back to neutral of movement of a driver. You can think of it that way too.
One full cycle.
Yeah.
Correct. And so at, at 80 hertz, that cycle is roughly, oh God, now I forgot the math here. Let me do the math here for a second. I have these numbers on the top of my head until I don't sleep very well.
About 55 feet divided by 4 or so. Yeah.
So 80 hertz is 18 feet long and 18 feet long. And then 20 hertz is
like 55 feet.
Is 56 and a half feet. And I normally have those numbers nailed, but I taught all day. I got up at 5 a.m. yesterday and my tooth fell out. So, all of those things. Yeah. So all of those things. So when you're talking about that difference in distance, even at one seat, that change is going to make a difference. So I can tell you in my I can't even call it a theater. It's at my office theater.
Sure.
Whatever you'd call it. That is 10 feet by 12 feet. It is small. I can hear a substantial difference, not only hear, but also feel because of that chest pumpiness, for lack of a better term, by using waveforming. I'm a big proponent. Take waveforming out of it for a second.
Okay.
You should have a minimum of 2, if not 4 subwoofers, and no matter what room you're doing. I've been saying this for years at CD, and this really was
too.
based off of Todd Welty's work.
Yeah.
And it is not, it's not because of volume. People say, oh, I need 4 subwoofers for volume. No, get 4 smaller subwoofers that would roughly cost the same as 2 larger ones because the wavelengths are so long that it is going to even it out. And then waveforming is just going to take it so much more. But yeah, it in my meager office, yes, it really does still make a humongous difference.
So we hinted at it before. You mentioned in the theater you're in right now, total of 8 subwoofers. Yeah, 4 in the front, 4 in the back. And so when we saw some of the very first images, like you were mentioning 2 years or so ago, when it very first was sort of mentioned and started showing up at trade shows and that, we were seeing diagrams, and they were showing fairly large rooms, enclosed rectangular rooms, and then we have a grid of subwoofers on the front wall and a matching grid of subwoofers on the back wall. And at first glance, to a lot of folks on home theater forums and stuff, they're like, well, that looks a lot like something called a double bass array, a DBA, where you've got an identical grid of subwoofers on the front and back wall, and there's basically like a timing difference between them so that the sound that's produced by the back wall is there to cancel. It's almost like active noise cancellation for the sound that's coming from the front wall. So that was first glance. People responded that way. And there's a mention of double bass array in the literature that Trinnov has on your own waveforming website. So, I mean, is it wrong-headed to think that the Trinnov waveforming and the double bass array have sort of a similar genesis at all?
Well, so if you're talking about genesis, sure. At the very beginnings of waveforming, it was okay. Well, I'm sure in Arno Labourie's head there was all right. Well, what can we do? And the other R&D guys for sure from a double bass array, and then improve it. So one of the difficulties with the double bass array is the fact that they need to be aligned right, and in many cases, like in this instance right here, I know it's hard to see, but there's a second row of seats
on a riser.
And that second row's on a riser, which makes it relatively difficult to have the same double bass array. So when we first came out, especially when we publicly announced it at ISE in 2023, we were like, yeah, it's basically based off a double bass array, and people would come back and say, oh, well, I've done double bass arrays for a year. That was the genesis of the very beginning.
Okay.
But this is way, way, way beyond that. And to probably jump ahead with your questions, but really kind of get this out, which is that, like, if I wanted to have the same number of subwoofers in the front and the rear, I can. But we have figured out a way to, if you need to do fewer subwoofers in the rear, there is significantly less impact than if you were to just remove, let's say I needed to do 6 subwoofers in the front and 3 in the back.
Okay.
We can do it. And you cannot do that with a double bass array. And if you have a riser, then you run into problems with double bass arrays. And so, and now, like, I'm doing waveforming in my room with 4 speakers. It is sure not a double bass array. I can promise you that.
Yeah, so, I mean, I've sometimes liked to say, like, the double bass array is one of those things where beautiful in theory, wonderful when you simulate it. You can do a pretty decent simulation of it in, like, Broom EQ Wizard. You can simulate that perfect enclosed rectangle of a room where every surface in that room reflects sound exactly, theoretically, identically off of all surfaces, and you can have it all set up that way. But then you try to actually build the thing in the real world, and it turns out it doesn't work quite as perfectly as the simulated theory. It seems to be anyway, the practical application of it.
Well, that's absolutely true, and it's also costly. There are, not only from a financial perspective, but also from a space perspective as well. So one of the things we did at CEDIA last year was we showed 12 subwoofers in the front and 12 subwoofers in the rear. And people were like, oh, my God, well, of course it sounds that good. You've got 24 speakers in there. We did not need to do that at all. The reason why we did that is because Ascendo wanted to be able to show that you can obtain infrasonic performance without infrasonic subwoofers if you have enough. And it kind of served two purposes for them, which was one, that yes, it's possible. And then two, it shows how much cone area is actually really required to be able to get infrasonics at that level. So no, we do not need that many subwoofers for sure.
And I think you also in that demo, or a similar sort of demo, like you actually had the ability to use all the drivers that were there, or to use a subset of those drivers to demonstrate what went on as you increase the number of drivers being utilized. Yeah,
for sure. And we here we're using only 8 only. We're using 8 subs, 4 in the front, 4 in the back. But then we also, like when I teach, so I'm teaching Artevo level 2 the next 2 days. And if we have time, we'll do a cylindrical waveforming, which is going to be 2 subwoofers in the front, 2 subwoofers in the back, and then they can compare the differences. The performance is not quite as good, but it's still fantastic.
Well, actually, that mentioned there, this idea of cylindrical wave, you mentioned previously the idea of a planar wave, a sort of rectangular shaped wave. This question is almost purely for Rob H's own edification. It's a bugaboo.
Why Rob's asking it, because I read it like 5 times and I still don't get it.
Yes, it's a bugaboo for me and maybe nobody else. But when I see people talking on forums about double bass arrays or about Trinnov waveforming, I've seen it described in a way that I think, and you're going to correct me if I'm wrong about this, but I think is a too much of an oversimplification. I hear people using language like, okay, there is this planar rectangular wave emanating from the front wall. It reaches those active subwoofer drivers on the back wall, and it's like, if they don't use the word annihilated, they're just like, it's gone. It's completely 100% absorbed, and it doesn't exist anymore when it hits the back wall. And I'm like, that isn't how waves work. You can have,
it's not,
areas where it's canceled and you hear nothing when you're standing in that area at that frequency, but those waves, they pass right through each other. Like when we're talking the actual fluid dynamics, they pass right through each other. They exist on either side of that location in space. And just because they're silent at one location, the wave hasn't actually been annihilated from existence. It still passes through. So I just wanted someone to say it out loud.
Okay, so now my tiny brain compared to Arno Lappery and some of those other guys. But first of all, so that the wave that is being basically produced in the rear, the absorber part of it, is actually not, it's timed so that it's actually moving a little bit forward before and synchronized. Now, if you look at our animations, you will see that we show that the majority of the wave is actually absorbed as in the rear. But you will then see in our animations, you will see a very faint wave that is then going forward. And then we show that then the actual front speakers then actually a second time, now the front speakers actually act as absorbers, and then they absorb the remaining wave that has come back.
Which doesn't happen in a double bass array. The front portion isn't doing a cancellation on that side of it. So that's certainly a distinct difference between those two. But yeah, it was like in my mind, I'm picturing how, like, when Yamaha brought out their digital sound projectors, and this is high frequencies, but being able to steer high frequencies almost like a beam of sound by using a gazillion small little drivers and focusing that wave interaction so that they have cancellations where you don't want to hear sound, and amplification, constructive waves where you do want to hear the sound. I'm like, well, in my mind, we're doing a similar thing, but at much lower frequencies, which is a much greater challenge to do. So I don't know if I have that conceptually somewhat correct.
I think you are. You're right. That is the general concept.
Okay.
The difference is there is a big difference between concept and execution, and the execution is really where the where
theory versus
where
reality again, yeah?
yeah, I can say I can make this work, but I can't do the math behind it. I will tell you, the first week that I worked at Trinnov, I wanted to kind of prove my worth, and I looked at this slide and had all this math, and then so I figured out the math and all that, and then I had a migraine for like 8 hours afterwards, and I'm like, oh my God, I'm not going to be able to work at this company. I'm too dumb to do this. And then Arno was like, oh no, that's just one of our PhDs in math. He likes to show off. I was like, oh, okay. But yeah, so there is a way to oversimplify this, but it is a very, very complex way that it is done based off of signal processing. So our roots are really in the fundamentals of signal processing. So it's not a...
That's exactly... that's what I wanted to hear, that it is more complex than just there's a literal square of a wave that doesn't touch the walls at all, and then it's annihilated at the back. I'm like, I don't think that's quite right. I think that's oversimplifying it.
I think that this is important for me to kind of stress, which is that, so like Trinnov announced a little while ago that we're opening up a headquarters in France. A new building. We're building a new building. The whole building, the majority of it is as a research lab. We are not a company to make false claims. And everything that we do is based off of engineering, math, and science. It's not, there's no voodoo. We're not like, these companies that say that, oh, well, here's a $7,500 cable and it makes the electrons defy the laws of physics.
Indeed.
It's not it. Our work is done in signal processing. There is no defying the laws of physics. There are just things that you can do to what is it? Every action has an equal and opposite reaction.
Compensate
and that's
for reality.
Yeah. So, and Arno has said this multiple times in his lectures and all that, which is that we're really kind of in the a renaissance for acoustics and our understanding of active acoustics. And that's really what we're doing, is that we're using active acoustics. And the things that we're doing now, waveforming, this is just the beginning of probably the next 10 years of how we can figure things out and improve the performance of audio in general.
Okay. So we want to key on the greater flexibility that Trinnov waveforming provides, and there's a number of subwoofer drivers on the front wall versus the back wall, and you're able to alter the precise positions of the subwoofer driver somewhat, and being able to choose the spacing of the subwoofer drivers in order to determine how high in frequency the waveforming will be effective. But we also want to ask how far that flexibility can be pushed in some different ways. So,
well, let me tell you about my room first. Okay. We'll start with this. So my room, oh God, I'm going to sound like Fred Sanford. Sorry. I just moved and I'm working on the outside of the house first. So the room is 10 feet by 12 feet. It is 7 feet 8 inches tall. And I have my washer and dryer in there in the closet, but the washer and dryer extend about 3 inches past where the closet door would work.
They're open.
So I don't have a closet door in there. So it is open. And I'm able to pull off waveforming and make a significant difference. I will show you. Now, you are going to have to please excuse the images of this. You have to realize how compromised this is. This is really, and just so you know that these are with the subwoofers not even raised, elevated all the way, because I'm doing testing, but I will show you this. So hopefully I have made a clear enough description of how terrible this room is. So, all right. Okay. So, and the thing about the waveforming is that you have all of these options that you can do with spatial deviation. And so if I look at, let's see here, spatial regulation off, let me go to the right ones here. Okay, well, I'll just do this right here.
Sure.
So you can see now number 3 is pretty terrible right here. This measurement number 3. And the reason why that measurement number 3 is terrible is because that's over by the washer and dryer.
Okay.
So I have 2 subs in the front, 2 subs in the back. The subs in the front are clipped subs that are ported subs,
Right.
and JBL subs are the absorbers, and they are non-ported. And we're always like, please, for the love of God, if you can, use both similar ones, so either ported or non-ported,
Okay.
but keep them the same. So you can know how compromised that is. But you can see that mean spatial deviation is better. It's nowhere near what we saw with the planar. But if we actually look at the wavelet, you can see how much more tight and precise that bass is.
In that time
so
domain
this,
again.
in that, oh my God. And it is infinitely better. And this is in an incredibly challenging room and in a very meager, limited subwoofers.
Sure, this isn't
so does that
16 subs in here.
Oh, no, it's 2 and 2.
Yeah.
And and this isn't even, I didn't even raise these to the height that they're supposed to be. These are right off of the floor. So yes, there is a lot of flexibility that you can have with waveforming. So
I mean that answers most of the ones we were going to say. Like
most of the questions.
It does not have to be literally identical subwoofers in every position. There can be somewhat of a mix. You're saying you're finding success even ported and sealed working together. You mentioned before, like you could have that option of, instead of saying, okay, to reach the output level that I want, here's the size of the sub that I need, but you could go a little bit smaller, but by using multiples of them, not to a gigantic degree, just like Harman's research was saying, you're getting maybe 3 dB more output every time you double the number of subwoofers in the room.
Well, so let me tell a little story. Hopefully I'm not telling too much here for Trinnov, but so we were doing some more research here in Connecticut, and Arno Labrie came out from France to do this. And because we have a nice space that they don't have in France till the building is finished. And so he actually bought, I think they were 10-inch Dayton Audio subwoofers, and we put them in the little cabinets that they have. So, I mean, we're talking about subwoofers that are about this big. And we did this in all sorts of different configurations because we just wanted to really kind of see, how do these perform doing this? How does this perform doing this? But you know what? Sounded pretty damn good to me. Now, these are 10-inch subs. They're not, and they only have so much power handling capability.
Right.
So it wasn't,
and they can only extend so deep, so you can't expect the infrasonic performance. They're just not producing it to begin with.
Right. So you're not getting quite the oomph that you wanted. But so ultimately, how it works is that, so like, a student in class today was asking about, well, what about the cubic volume and all that? And it's like the cubic volume is based off of the subwoofers that you buy. It's not based off of waveforming.
Right.
What matters for us is, like, if you see our design tool, and the design tool is live now on the website. The design tool and then the measurement tool. We actually have a measurement tool that just launched today. And so basically what happens is the closer that you can pack the subwoofers together, the higher the frequency that you want to control, you can do it. So that's where the number of subwoofers comes in. So when I showed you the Trinnov headquarters one, and we saw that linear line that went all the way up to, let's say 80, 90 hertz or whatever. That's because we were only using 4. If we did 6 subwoofers, then we would have been able to get that number higher. So that's kind of how
120,
it works.
150 hertz, something like that. Yeah.
Well, probably closer to 100, maybe 120. Okay. But we have black swans in there, and black swans take up a lot of space. So we wanted to say, okay, well, our compromise is that we're going to go a little bit lower in frequency for what we're going to get the greatest control of. but while being able to play Black Swans for LCRs.
So one topic that comes up for quite a few of our listeners, they have their, primary couch. It's facing the TV. It's away from the walls and that, but they also have couch for guests. It's over on the side. It's pushed right against the wall, or they have 2 rows of seats, but they're in a smaller room. That back row is right against the back wall. They got no room behind there. And in traditional setups, even if you're using more than one subwoofer, we'll often find okay, those seats that are pushed right against the side wall, they're just never going to be as good as the primary seats.
Right.
And you had that indication, when you measured right over by your washer and dryer, okay, that one was a bit of an outlier. It didn't look as uniform as the ones that you measured in your actual seats. So I'm like, there must be some limitation to it. It can't literally make every inch of the room identical. There's some limitation, I would imagine.
No, there is some limitation, and we do recommend that your seats are at least 1 meter from the absorbers. So those seats right back there, the subs that we have now from Ascendo are fairly deep. I think they have a new version that's coming out that's more shallow. Mm-hmm. And so we're relatively close. So the performance is not quite the same with that back seat as they are on the front seat. And so we do recommend that you be 1 meter. But no, we're not going to say that this is going to be perfect for everything, because it's not. However, we are going to reduce the amount of resonance in the room. Right. We are going to remove that decay time. So
I love that you're saying it, not trying to claim that it's magic. I love that.
Well, the truth shall set you free.
Right. You keep talking about this kind of goes into one of our questions that we're going to ask, but you talk about the front wall, putting the subs on the front wall as the emitters, and the back wall are the ones that catch the sound. Is there a physical reason why you need to have the subs at the front of the room doing the emitting? Could they not be on the back if you have more room back there, or on the side wall and have the subs side to side? Does it have to be front to back? Is there a reason for that?
Yes, it has to. It has to be front to back, just because, I mean, I'm going to say that's probably a good question. That could you theoretically do those on side and side?
Yeah.
I don't think we have ever tested anything to that nature. So right now I'm going to say no, but I think in general, the principle is that you, those are the walls that you're going to put your speakers on. I think that, a natural, I have no information. This is speculation. Okay. This is taking me out of Trinnov. This is taking me as just dummy Dave. That ultimately we'll probably be able to figure out, using other speakers and those kind of things as well. So that location might also be beneficial down the road.
Obvious reason I ask is that not every room is deeper than it is wide, and that's kind of what the assumption is here. Many people have their rooms wider than they are deep for various and sundry reasons, and there are people who have more space behind them rather than in front of them, where the screen is, and the TV, if they're using a TV instead, that sort of thing.
Well, and I had a bit that tied into that, which is that in a lot of the diagrams of the demos that we've seen, it's naturally, if we're having subwoofers that are, they're not just front wall and back wall, they're also they're raised up. They're not just on the floor. So we've naturally seen, typically the setup is a projection screen, large projection screen, acoustically transparent. That makes sense. But it's we got 115-inch LCDs now. It's what if somebody puts the subwoofer drivers behind a flat panel? Maybe they could shift it to a side to side or something like that. If that's even a problem. I don't know if it is.
I think testing needs to be done. What I will say is, in my, god awful room again, the 10 feet is the front to back. The 10 feet is not the 12 feet. And so it's very funny.
That's essentially the same dimension.
Yeah.
I mean,
it is. It is. But the actually the measurement is not the same. So when I'm measuring it, I actually taped it out and I got this little tiny square, but it works fine. But I don't see why it would not work. But other than the fact that like as we're getting to the crossover frequency and stuff,
Right.
and as sound is becoming more directional, that might become a problem. But
Right.
um,
So,
I will just say that I'm sure at some point in the future they will test that to see if
well, you got
that
to start
works.
somewhere. I understand that. I guess,
Yeah.
because,
Yeah.
I'm asking because that's going to be like people look at when they listen to this or watch our video, they're going to be thinking about their own rooms, and their rooms
Sure.
aren't necessarily, always deeper than they are wide. And a lot of times they're not even
Right.
rectangles. We get a lot of open
Yeah.
concept stuff, and, rooms that are in bonus rooms that were in attics. So they
Yeah.
got
Or
a
it's a
weird
great
ceiling,
room, or they have
angled
a
ceiling.
loft or stairs that open up to downstairs, all kinds of things that are not enclosed rectangles, right?
Yeah, they're in a basement with
Yeah.
a stairway that goes up, and there's no doors anywhere. How well does this waveforming work in a room, or as you get further and further away from these rectangular enclosed spaces?
I think as you get further and further, it is more challenging. Now the decay is probably still good. I don't think we've done enough testing to be able to make any definitive answers on that. Every single theater is it- you know so when the RP22 that is all of us these days, it is a revision of the old CEB22, which was the home theater audio design recommended practice. And actually, I was the chair of that back in 2007 when we started writing it. But it was really Tony Grimani and Todd Welty and Floyd Toole and stuff like that. Amazing people. And the first paragraph in that document was home theater is all about um, uh, uh, compromises. That it is compromise, and there is always compromise. And we can, for now, only tell you what works best in a regular enclosed room.
Okay.
Right.
What I would say,
we warned you. We wanted to push the limits of this
no,
flexibility.
no. But what I would say is in like these bonus rooms or these open areas, the harder part is actually going to be the cubic volume than anything else.
Okay.
And I don't think people realize that when you have like an open room,
Yeah.
the cubic volume just gets absolutely massive. And they're like, well, why don't I have any punch in my bass? And it's like, because your room is ginormous. So I am interested to see where we go in L-shaped rooms, not linear rooms, those kind of things. But it kind of goes back to, I think we're at the beginning of our understanding of active acoustics, not at the end of it. So we, what I would say is if you got an altitude, try it. And what I would say even beyond that is now that the waveforming software is open and anyone can use it, you get your results, send them to us. And the other thing is that we're a support company first and foremost. Like, we want to help people. So if you have questions, if you're not sure, you can just send an email to waveforming@trinnov.com, and we will try to give you the best educated guess we can. We're not charging you for that. I'm sure the demand is going to be pretty great, so it might take you a few days to get answers back or whatever. Especially just we're a French company, so they take some of August off. So there's that. But I think that ultimately we will get there, but it's going to take more time, more studying, and then ultimately more math.
So we have touched upon quite a few of the things that we were considering asking next, and we don't want to keep you crazy long, but you said you're willing. We love everything that we're talking about here. So we've touched upon, you've mentioned those names, Dr. Floyd Toole, Todd Welty. You're clearly familiar with that Harman research. That is something that Tom and I have been championing ever since we first came across it, because it made so much sense. And then we tried it for ourselves in our rooms, and we're like, gosh darn it, that works a whole lot better than one sub under my left speaker and one sub under my right speaker. It's remarkable stuff. Those ones, like that multiple subwoofers, white paper that we reference often, done by Todd Welty et al., printed and publicly available from Harman for free. Love that they're not charging anybody for all that stuff. But that, in a somewhat similar situation, it's like, ideally, enclosed rectangle of a room. In their scenario, 4 subwoofers either at the 4 corners of the room or at the midpoints of each wall, but all playing in mono. So that's a pretty big difference between that, what we might call the classic multi-subwoofer approach at this point, versus Trinnov WaveForming. But you're talking, your own room, you got 4 subwoofers. They're not elevated, as you mentioned. You're using waveforming. So we're just like, okay, how close are we getting if we do that 1 subwoofer in each corner of the room versus what waveforming is offering? Because we definitely know when we have a subwoofer in each corner of the room, we have improved seat-to-seat uniformity. It's certainly better than a single subwoofer in the room. We have improved, in the time domain. We have lessened room modes. So it's like, it seems like similar things have been achieved, but what is waveforming doing that's going to the next level beyond that?
So basically what we would say is we have 3 levels of waveforming. Now it just means what the performance is going to be. There's no difference in the setup, the capture and the calibration, those kind of things. But what you were talking about is what we would call conventional waveforming, which is, for lack of a better term, 4 on the floor in the corner. Mm-hmm. And really what it's not going to do is it's probably not going to make a big difference in the mean spatial deviation between seats. Much compared to your cylindrical or planar waveforming. But what it is going to do is, it's going to better it, but you're not going to get down to that 1 to 2 dB. It's just pretty difficult to get that. But you still should make a big improvement in the decay time. So you're not getting that massive ring or echo that's going on in the room. So, and I think that over time, we will be able to improve that as well. So,
like in my head, when I'm just envisioning sort of some of like what's going on fluid dynamics wise, I'm thinking, okay, in the considerably larger room, in all dimensions, including height, and you're able to do more than 4 subwoofers in Trinnov WaveForming style, which clearly is an option, right? You can do what, like 6 subs in the front, 6 subs in the back. That's one that shows up right there in the configuration.
Or 6 in the front, or 6 in the front and 2 in the rear.
Right.
Because remember, you don't need to have as many in the rear to get good effect. So it's not as sensitive compared to the emitters. Just to be clear.
When I'm seeing that, in my mind anyway, it makes sense. Like, okay, we are doing something quite a bit different here because we're doing much more something like we mentioned, a little bit of steering at base frequencies, which is nigh impossible to do without a very complex setup like that. We've been focusing on the lowest end configuration, the 4 subwoofer configuration, simply because most of our
most of them out there. For sure.
Most of our AVRant listeners are using smaller rooms. Obviously, there is a financial consideration that goes along with that. 4 subwoofers cost less than 16 subwoofers, that type of thing.
What?
Yeah. Yeah, right. And then we've also talked about like there's this free multi-sub optimizer software which doesn't send a mono signal to 4 subwoofers if that's what you're using. It will actually tailor individual volume and phase and equalization for 4 subwoofers with the goal of getting as good uniformity from seat to seat. Now, the immediate thing that jumps to my mind is in that multi-sub optimizer software, you're kind of limited by how many measurements you're willing to take because it'll do its best at creating that uniformity across all the measurement data that it has. But if you only give it 6 measurements to work with, you're not going to get, great uniformity throughout the whole room. Waveforming sounds like you're going to get that excellent time domain and uniformity like almost as a side effect of just doing it correctly.
Well, yes, that is true. But the other thing is like you don't have to use waveform. So let's say if you had a Trinnov, you've got a Trinnov. Our base management I'll put our bass management up against anybody's any day of the week. Like it's amazing. So if you wanted to do 4 subwoofers all individually measured, you can do that. Or we have ways to do, let's say, 4 mono subs if you wanted to do mono subs. So you don't have to use waveforming. Right. It's just another tool in the kit for you to be able to use. But yeah, I mean, there's all sorts of stuff out there. It's just bass is the hardest to deal with. Yep. And
it's so room dependent.
Yeah, it really. That's the other thing is it's like if you take a room that's got 10,000 cubic feet in it and you put 4 subwoofers in the corner, I don't think you're going to get all that great a performance no matter what you do. I mean, I guess if you used 4 32-inch infrasonics, you could, that might work. But ultimately, the room is so important. Yeah. The room is really, 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 really important. And the thing is that, yes, Trinnov is expensive. We understand that. And there's reasons for it. But it does not mean that you have to have the world's most expensive room or the world's largest room. It can be in the smallest room. It can be in media rooms. I mean, I expect to see waveforming going in lots of different applications over the next couple of years. But this is certainly the kind of the beginning, and it's exciting, to be honest with you. And I'm glad that we finally have the software out for anybody to implement.
Yeah.
So I've got a couple of questions that are on this list. So Rob, sorry, going off script. The first is something I think we should ask at the top, which is, how does this process work? Like, how do you set up waveforming in your room? You've got your subs.
I mean, that might be a whole hour, so I don't know if you want to point to the resource.
Yeah, well, that's what I was going to do. So give me a second, and I will pull up.
So first, you after positioning the subs, you can get by putting in your dimensions of your room and all of that.
Using the online tool, it does a great job of helping you visualize where you're actually going to physically place your subwoofer drivers.
Right,
but I imagine. Go ahead.
So let me show you this, because I doubt you've seen it, because it literally just went on the website today. So I'm going to share my screen again. Share screen. I need to, entire screen. Okay. All right. You've probably seen this, which is the subwoofer layout.
Yeah.
Yes.
Which is, so just real quick, basically you put in what the dimensions of the room are. So 23 feet by 9 feet or whatever. And you can drag this around and it'll tell you how many. Right. So we have determined the subwoofer placement. So then what we can do is we can then go to the measurement, and it will tell us, how many rows that we need. And it will tell us how many, where our measurements are. So here's a screen. Okay. We have 2 layers of, basically we do ear level, and then we do roughly 2 feet above. And then we don't want this diagonal right here. We don't want more than 1 meter of distance between it. And then so you can so here, let's say,
and this would all be using Trinnov's tetrahedral microphone that comes with the altitude processors.
That's right. Okay. That's right. So this is above the measurement that you're going to take for all your main speakers. So basically, which is kind of nice, because when you go do the measurements, you select subs only. So after you take your measurements for all your speakers, then you just do sub only, and it'll just, you move the speaker or the mic to these positions, and you don't have to make sure that the LED is facing the center. But you put them in these positions. You have 2 different heights, ear level, height level, and then you just do the measurement, and it just measures the subwoofers. And so I can typically do a waveforming calibration in a room this size. This is a big room. I can do it in about an hour. Okay. Now, I will say I've also done it a lot. So,
first time
because we're
user,
doing
it might
tests
take a
and
little
stuff.
longer.
Yeah, I would probably give you 2-3 hours first time, because you have to just kind of get accustomed to, okay, well, I'm moving these in kind of a grid, and I'm also doing them in 2 heights.
And physically, you are actually, each subwoofer is connecting to a separate preamplifier output on an altitude processor. It's not like we're splitting a single sub pre-out to all these multiple drivers. Each one's getting its own individual pre-out signal.
Correct. The only one in our system like we have here is the infrasonic, and that is not even, for lack of a better term, treated as a subwoofer. We have a trick. So if you want to add an infrasonic, you talk to us and we'll walk you through it. But yes, so the interesting thing is that all of the subwoofers have their own independent output, and that's because of all the timing that has to be done.
Okay.
However, when it is done, it acts as a single sub.
Right. All those drivers and the room become one bass producing thing. Yeah.
Correct. Correct. That is correct.
So I had a question, because you mentioned this, right? Director's intent, creator's intent. And I'm just curious. I'm like, I don't personally know of any mixing and mastering studios or dubbing stages that are using waveforming yet, although you hinted maybe some actually are. But I'm just like, okay, not yet. All right. So if the content is not being created with a waveforming system, then, like, were they maybe counting on there being some more time domain smearing, some more reverberation, because that's what they might have heard when they were mastering it? Were they counting on that? Are we actually, like, is it too clean? Are we away from the creator's intent because it's too clean?
I don't think so. Okay. So 2 reasons. One, so I have a good amount of experience in absorbing and treating recording studios, even though I have no idea in God's green earth how to actually master anything. If you look at these, they make the absolute driest rooms ever.
Yeah.
I mean, they are incredibly.
They're not literally anechoic,
but they're close. I mean, it's insane. I mean, there were guys that were mixing and stuff, and I mean, it's feet of absorption, and so they're doing it in very dry rooms to begin with, way under 100 milliseconds of broadband if possible. So that is the case. Now, right now, waveforming is only available on the altitude line, but I can tell you that there is a lot of interest, because we also have products in pro audio and in commercial cinema. So there's a lot of interest for there, but we got to, nail this first, and then, but no, you're not hearing it different than if it is a well-mixed track. I can also tell you that there are a lot of differences, aka Christopher Nolan. Can I tell you
it's
exactly?
Nice when somebody else comes on the podcast and beats up on Nolan other than just me. All I do, I don't even know the man, but for some reason, I just can't help but beat up on him every time I get a chance.
I mean, I love The Dark Knight, but it ends there. So
I will say, so that kind of leads into one of my other off the list questions here, which is, we haven't really talked about acoustical treatments of rooms. Now, we've been advocating for, obviously, room treatments help way more in the top end. This stuff is way lower than that, and the very little bass trapping gets anywhere near these frequencies. But there's still going to be people who are worried, hey, I did all this room treatments, I did all this stuff. Is that going to make waveforming worse? Is it going to make it better?
No.
Is it going to make no difference?
No, it's not going to make it worse, for sure. Here, I'm going to take an aside for a second and say, for the love of God, please do not put a half inch of foam or something across every surface of your room. I was in Indianapolis, and a dealer out there was so proud when I was working at Orlex, and he's so proud to show me. And I'm like, oh my God, that is the worst idea, because all you've done is just made the room completely unbalanced. And the other thing is that people add too much treatment. But we we want you to add treatment. But no, if you seriously treated the room, no, it's just going to make waveforming's job easier.
Okay.
And that's ultimately when we say that, look, you're buying a Trinnov, but we still want you to treat the room. That's because the better the sound is, the fewer the filters that we have to put on.
Right.
And so we definitely want a nice kind of combination or an ecosystem where the room already sounds good. All rooms are going to have flaws, and the fewer flaws that we have to fix, the better off we're going to, it's going to be.
So you've been so generous with your time, and the focus has been waveforming. I had a couple questions outside of waveforming to do with Trinnov, but before we get to those, was there anything about waveforming that we haven't asked yet that you really wanted to touch upon today before we leave that specific topic?
No, I'll just say it's freaking awesome. It's amazing. And I could watch John Wick's More Firepower another 1,000 times, and I'll be as happy as a clam. So
just for funsies, when it comes to those Trinnov altitude processors, what is the actual maximum channel count you can get up to these days? Because like we had those names, right? We had altitude 32, but then that actually kind of became a 36 because it got, extra expansion. And then you had like the altitude 48 with the expansion. So it was adding 16 more channels. But I'm like, is that actually like an altitude extra 20 channels? So like, what is the actual maximum you can get to these days?
Oh God, this is deja vu all over again from this morning. So, okay. So we have to explain the difference between your discrete channels and channel count. So according to Dolby, and Dolby has the highest discrete channel count, it's 35 channels.
Right.
34.1 is the highest one that you can get in the residential side.
24.1.10, right? They divided out that way for Atmos,
Yeah. So then the question is, well, why would I need a 64 channel? Because the answer is 64.
64. So is that starting with the 32 and then 2 of the 48 expansions?
Yes, the 48 extension, you can put 2 48 extensions in there to get you to 64 channels.
Gotcha.
However, so really that would the only reason you're going to need that is if you have got a lot of active crossovers.
Okay.
So when
or that many subwoofers? Could you have that many subwoofers for waveforming?
Well, ish, yes. So you can add more as long as it's the same channel. Then yes.
Okay.
So you can do it that way. But so like I'll give you an example. In this theater when we first did it a little over a year ago, we were using the old Ascendo speakers, and they were all needed active crossovers. So we had to use an extension 48 for it. And then they're like, hey, you're putting in waveforming. Can you put in our new speakers? They have passive crossovers. So then we could reduce from an extension 48. But let's say you're using Wisdom as an example, and they all need 4 active crossovers. You can chew up those channels very quickly. So an altitude 16 can get 20 channels out. Right. An altitude 30, because we figured that's another thing where we didn't charge for it. We just said, you know what? We figured out a clever way that you can add 4 more channels. You just have to buy a separate DAC.
Yeah, because you're sending out like stereo PCM from the digital coax, so then you have to just convert that digital to analog, and now you got more pre-outs. Yeah. Yes,
except for the fact that we're also optimizing it, so those are optimized channels. So, we you can get 20 on altitude 16, you can get 36 on altitude 32 at the +4. And then you could add 2 extension 48, so you can get to 64 channels. That is very rare. It's very rare. It's very rare that anybody does an extension 48 too.
I mean, I think it's relatively rare that someone actually does 24.1.10 strictly for Atmos. Although, I don't know. Maybe I'm wrong about that.
Right. Right. Well, you know what? There are people who have money to burn.
I suppose. And then you can quite easily go beyond that, because if you go, oh, well, the Oro specific ones, if you have separate channels for those, then those goes beyond the 34. And then if you're like, DTSX, they actually prefer that your height speakers are at 45 elevation and 45 azimuth. So you could have separate heights for DTSX only, right?
Yes. And we have the ability to basically say, if it's this codec, use this speaker, because it's not native to it. So we can move things around to wide speakers if we wanted to, or overhead, or however we wanted to do it. It's infinitely flexible.
So I had another almost purely Rob H edification question, because
this is a Rob H one for sure.
Yeah, people might know I'm a fan of front wide speakers.
Oh,
my experience with front wide speakers is something that I cherish, and I'm the front wide fan around these parts. Tom might not agree with me, but there's been a whole thing, quite a few people who are also front wide fans. One of the fantastic things that those Trinnov Altitude processors offers is a graphic visualizer, so you can actually see in a Dolby Atmos object-based signal, you can have a visualization of where those sounds are moving in the mix, which I don't know if that's actually unique to Trinnov, but I don't know anybody else who's doing that. Certainly not in a user-friendly way, if it even is possible.
I do not know either, to be honest with you. I really, really don't. I would say that I'm going to say it's unique, not knowing whether it's unique or not.
But thanks to that visualization, people have noticed there are Ultra HD Blu-rays or versions from Kaleidoscape. You use that visualizer, you're looking at a Dolby Atmos soundtrack, and they're like, wait a second. All of the sounds in the floor level speakers are actually fixed channels, because Atmos can use channels and audio objects. And they're like, it's 7 fixed channels for the floor level. The only objects that exist are strictly in the height layer. And if I put my ear right up to my front wide speaker, it never makes a peep, even though, it could. Is Trinnov capable of, quote unquote, fixing that and having some sound coming out of the front wide? Because I'm like, Trinnov seems uniquely qualified to do exactly that, because you have that remapping feature that says, hey, look, if you have to physically put a speaker not exactly where the Dolby diagram would have you put it, we can create a phantom speaker by utilizing processing between adjacent speakers to make it sound like the sound is coming from exactly where we want it in the diagram, even though the speaker isn't physically there. So I'm like, can we make those front wide speakers make some sound even if the soundtrack doesn't actually have sounds mapped to that location?
1,000,000%. It's not mapping though.
Okay.
It is arrays. And so basically we could say, okay, well, you know what? That in this format, I am going to basically make my left front and my left front wide play the same. So I can actually make my left front wide. So basically in the speaker layout tool, we have the codecs, and we could say, okay, well, with this codec, there is no front wide. So since there's no front wide, play left. And then we will get the sound to do that. So
can it do matrixing to create a phantom front wide, similar to how you would create a phantom center if you didn't have a physical center speaker? It's just taking the equal parts that are in front left and front right, subtracting it from those and playing it out of your center. Phantom, can you do that for not precisely that? Okay.
Not at this point. So if you want sound to come out of it, we do an array, and it comes out that way. And part of that is the codec may or may not, and there can be broadcast flags and stuff that are in there that state that this is what you get. Like, a lot of the Marvel movies, as an example, you are getting 7.1 and 4.
Right.
And that's it.
And even though they're technically objects, they're used like channels in that they just physically never move in their 3D coordinates, right?
Yeah. And so some of that is at the mercy of the content creator as well.
Yeah,
well, not the content creator, the content owner.
Right.
Yeah.
some of these, they're very precious about how things sound, and they lock it down.
I might as well cue you up for one that I know Trinnov has a pretty unique ability, which is when it comes to the upmixing, right? We got Dolby Surround upmixer, DTS Neural X upmixer. We've seen in the consumer level, get it at Best Buy type of AV receivers. Only certain ones, if you have more than 11 speakers, only certain ones will ever put sound into more than 11 speakers when using those upmixers. And that seems to be like a chip-based thing. They have to buy the specific chip that has the version of the Dolby Surround upmixer that might put some sound into your front wides or might put some sound into your top middles via upmixing. Trinnov, again, because you're not using like system on chip, right? I know that you guys were like ahead of the game as far as that upmixing flexibility goes, right?
It's the processing power. It's why we have a PC that is also in the machine. The PC is really used almost exclusively for number crunching. So that's what it's doing. It's crunching all the numbers. So the power is infinitely more powerful than anything out there that's on the market, for sure. And so it's just a numbers game. And so the lower price ones, they just don't have the processing power, the RAM, to be able to do that. So just it's not a knock on them. They're doing the best within the constraints that they have.
Sure.
So when HDMI 2.1 was introduced, the altitude processors didn't get it right away. It took some time before the Trinov's HDMI 2.1 upgrades were available to existing owners. We just love to talk about HDMI. So is there any insight you'd be able to share about why that is the case with HDMI changes?
Oh, okay. So I spent years at CEDIA overseeing the writing of documents, just writing how to understand HDMI. I got lucky enough. I personally got Steve Venuti, who was the chairman of HDMI, one of the nicest, greatest dudes in our industry ever. Amazing, to come and speak at CEDIA, and this is like 2009, 2010, when it was horrible problems. And dude shows up in a shirt with a bullseye on the front of his shirt. It was amazing. So, yeah.
Okay, some self-awareness. I like that.
Yeah. So when it came to us, first of all, there wasn't really a lot of content out there that required HDMI 2.1.
Sure.
And then the board manufacturers, because we don't manufacture the HDMI board, we actually use Cypress to make our HDMI boards now, and they had a long time developing it. And once it was developed, we had lead time. So we really literally just, our new units launched the HDMI 2.1 board at the beginning of the year, and there's just so many really difficult parts with it. The high frequency that you're doing, the high bit rate that's going through it. For us, we ran into a problem where it was one single capacitor.
Oh no!
That capacitor number 13, I think, one single little capacitor, and it took us months and months and months and months to find out what the problem was. Not on the, it was basically, if it was a unit that was factory installed in a clean, like you're wearing a white suit and all this, it worked fine. But if we wanted to do an upgrade from an existing 2.0 board to a 2.1 board, capacitor 13 was really, really sensitive.
Got to build a clean room to do it.
Yeah. Well, no, you gotta use microscopic soldering, and
wonderful.
And so it really is pushing the limit of what the technology was. I think it's telling that. So in the beginning of HDMI, it was a new standard every 3 years.
Right.
So and iterative ones in between. So HDMI 1.3,
Sure.
1.3a, 1.3b, 1.4, and we haven't had a new HDMI standard since 2.1 in 2017. I was still working at Cedia, and it's been over 6 years since I left Cedia when HDMI 2.1 was announced. And that is because
they're going to get
standard
CEP to work, so don't worry. It's almost here.
Well, standards are more easily developed than the hardware is a lot easier to implement the standards to what the hardware is than as opposed to like all the recording studios and those kind of things.
Right,
so the other thing was the demand wasn't there. And then the real hard part was the actual timing of the HTCP, the copyright protection. It went down it went down in HDMI 2.0. Now it's been 6 years since I talked about this, but HDMI 2.0, it was 5 seconds, and in 2.1, I think it's 200 milliseconds.
Sure.
So there's all these little iterative changes that just made it so hard to get it right. And we, as Trinnov, did not want to put out something that was substandard as well.
Right.
So we wanted to make sure that we got it right as well.
Your customers expect it to work and work well, yeah?
Well, not only that, our dealers. So I don't think enough people think about the impact that a flaw in a product causes the dealers, because that truck roll is costing them money, and it's also making them look bad. So we don't want to do that either. So it's a whole ecosystem, the end user to the dealers, and then ultimately our reputation.
Folks, can you tell this caused a little bit of consternation? It's not just Tom and Rob who complain about HDMI sometimes. My goodness.
Well, that's weird.
I mean, we thought we were good to go, and then 6 months later, we're still figuring out what this is, and that puts a strain on other resources.
Yeah,
it's hard work. If you're a Sony or something like that, you can have a whole division working on this, but
we talk about that all the time.
Yeah, it's hard.
I mean, Trinnov is not a tiny company, but compared to somebody like Sony or Denon and Rant, they're huge. They could just throw people at a problem, whereas a problem comes up for you guys, and it's a big deal. Everybody, it takes time and resources, and that's you can reduce one of those things but not the other. So everybody's pretty excited about over at Trinnov about the release of waveforming, I'm sure. So where can people find out more information about Trinnov waveforming and Trinnov audio in general? Where should they go?
So if you just go to trinnov.com/waveforming, all the waveforming information is going to be there. Or you can go to just trinnov.com and look under resources, and we have a whole bunch of resources, including waveforming.
And if people want to reach out and talk to somebody, is there a place they can contact, or can they reach out to you directly? I don't know if you're open to that.
Yeah. So, I mean, that's my deal. So you got a couple of things. One is if you want waveforming, information, waveforming@trinnov.com is a great email to go to.
Okay.
You want to reach out to me, Dave.Pedigo, Pedigo. Sorry, I lost a tooth, now I have a retainer. So that is a G as in George.
Even it's not just me having problems with people's names. You see?
Oh, yeah.
Everybody blames me like it's got a problem. This man can't say his own name. What do you want me to say?
I ate paint chips as a kid. What can I say? So Dave.Pedigo@trinnov.com or Twitter @Dave Pedigo, and I'm happy to help you. We want to help people for sure. We know that there is going to be a inrush once people realize that now it's available to the public. So please excuse us if it takes us a few hours or even a day or so to get back to you, but we will absolutely do our best. And then if you don't hear from me in a day, email me and say, "Hey, jerk, you didn't respond to me. Can you help me?" So, we're here to help for sure.
Just to hammer it home, if you already own an Altitude or if you're planning to purchase one in the near future, waveforming not going to be an upcharge. You're not going to have to pay extra to implement that. Well, I mean,
$0
premium.
no premiums. Now, you might have to have enough charge for subwoofers.
Right.
You know who loves us right now? Subwoofer manufacturers.
Yeah, they got eaten this.
I'll bet XLR cable manufacturers have a pretty good relationship with you too.
Yeah, yeah, for sure. For sure.
So you did mention, and I specifically, this clicked with me. You did mention, hey, if you have a non-standard room and you try waveforming, send us your information, and we'll take a look at it. If people really wanted to do that, what should they send you?
Well, I think what's going to happen is ultimately we're going to have a simulator. So I think it's going to take a while for non-standard rooms for us to really be able to make educated guesses on those. So for now, what I would say is just send it. No matter what you're doing, if you got questions about the project or whatever, just send us an email. And if you can describe what's going on, if you have a room layout, like, just a bird's eye view with the dimensions, that would help for sure. So we're not going to right away be able to do very complex 3D simulations of everything, because we're going to get lots of requests. I'm thinking that
they're sending it to you for your edification, so that you guys would have more data. Hey, this is this room, but this is what the results were, sort of thing.
My apologies.
You see what I'm saying?
Yeah.
Like, if they've got a Trinnov and they set this whole thing up and they run, can they send you their before and after measurements and the layout of their room, just so that you guys, hey, well, this is these rooms that people have used it in.
Oh God, yeah. So what we would love is any information you can provide, like the dimensions of the room or whatever. But then just screenshots of the before and after graphs would be great. Would be absolutely terrific. And just real quick, one thing that we didn't touch on is the other thing about waveforming is that you have the ability to adjust the strength or weakness of the waveforming in various iterations. So I could also say, you know what, I'm going to set my waveforming to strong for movies because I want the impact. But I like reverb sometimes, and you can reduce that as well and just save that in a different preset as well.
That really is active room treatment, in that it's almost like you can add and remove panels in a sense, but it's not physical panels. Yeah. It's a adjustment you can make in the processor. That's cool.
Yeah, cool. And so if you have screenshots of, okay, well, I did this and this is what I set my limiter to, or whatever, that's helpful, so that we could say, okay, well, that's it. But we love our customers. We'd love to see what they've got, and eventually we will be able to also then figure out these non-traditional rooms or whatever. But anything that they could do to help us, and that'd be great. I should give a shout out to our beta testers. We have beta testers who've been beta testing the living crap out of waveforming over the last 2 years. And they are some passionate dudes. Yep. And not a single female waveforming beta tester, kind of disappointing. So,
Seems non-representative. I think you should start over. All right.
Yeah.
Well, Dave, thank you so much for spending some time with us tonight, today, depending when you're listening to this, and in introducing us to waveforming and giving us this great insight. We really appreciate it.
Oh, the pleasure was all mine. I could go for another 2 hours, and I just talked for 8 hours. So you know what? I'm not kidding. This is great. I'm really happy, and you guys were a joy to be with.
Oh, thank you so much. Thank you for being so generous with your time, Dave. It's an absolute pleasure.
You're welcome.
Well, that was an interview with Dave. That was long, I'm going to say.
But I was very, very pleased with how things went, and Dave was fantastic to talk to.
Yes.
As I mentioned right in the interview itself, it's like not your stereotypical C-suite executive. He is hands-on with this stuff. I mean, head of training as well as being COO. So, he's very much up on the technical side of these things, and you heard the way that he spoke about it. This is a man who is just as nerdy and geeky about home theater as the rest of us. So, that was a lot of fun.
And I know you guys are probably just as impressed as I was that he is using waveforming in his theater with just a couple of, 4 technically, mismatched subwoofers and getting good results.
Yeah.
So, are you going to run out and buy a Trinnov processor just so you can put it in your tiny little bedroom system in order to get waveforming? I mean, probably not. Let's be honest here. It's a lot of money for a Trinnov system. But at the same time,
right.
I mean, this is some pretty impressive technology that they're sporting. Now, I do very much, and you heard this throughout the podcast, I am very curious as to how they're going to get this to work in non-rectangular rooms.
Right.
And I also would love to hear them just admit that you can put the subwoofers on any two opposing walls, and it doesn't have to be across front and back. I don't see why front and back should make that much difference.
Some of that, I mean, we are recording this outro after, like a week after the interview, so a little bit more thought that I've had about it. And I mean, there is the part of the Trinnov system that is integrating the bass that is created with whatever. I mean, as Dave pointed out, it's not as though this having introduced waveforming means that you can't use the traditional multi-sub ways that we did things, either, you know, all mono or like their version of multi-sub optimizer that already existed prior to this. You still have those options, but part of the Trinnov system is the integration of whatever you've done on the bass side of things with the front speakers, that whole crossover scheme that they have within Trinnov. So I imagine some of that with that timing in their current algorithms is assuming that the emitters are at the front of the room. That might not have been explicitly stated during the interview, but that's some of where that little bit of hesitancy, I think, from Dave was coming from, is that integration between all of the, you know, upper frequency speakers and the bass producing thing.
Plus this is super new and super,
that's right.
High tech, and then they you got to limit variables when you're trying to roll something like this out. We're like, for now, everything's got to be this way, because we don't have. I mean, the minute we start changing things, then who knows, you know, how much more time it's going to take. And it works. It works the way we have it set up right now.
And since they are putting out guidelines, not just for professional installers to follow, but now for all public people who might own a Trinnov altitude processor that is just publicly available, public information now you can find on their website. I think they would be running the risk if they were just like, quite literally do anything in any room. You can't make that promise. There are, this is not magic. There are limitations to, like, look, here's what we know works from our own testing. So that's what we're going to like say are our guidelines for how to set this up. I think that is perfectly fair, because otherwise you get into that problematic territory of someone sets up something way outside the parameters and then goes, hey, why isn't it perfect? You know, that's really not fair to Trinnov.
And that's going to happen anyway. So there's going to be some Reddit a-hole who's going to set it up all stupid in their, you know, their room that's inside one of those dome things that they build. You know, we have that place off of I-4 that you can drive by, and they basically they just build these dome houses, and it was like, man, the acoustics in there must just be awful.
But also, for
it
folks,
is very interesting.
For folks who were wondering specifically about that question of, hey, I already have 4 subwoofers. I've done the more, you know, classic or traditional Todd Welty type of setup, or I've used the multi-sub optimizer software. Why would I, a person with already 4 subwoofers, consider paying the money to get a Trinnov altitude and do that? I asked that question during the interview, but again, a week later, there's been a little extra thought. There is a difference in almost on the philosophy side and then on the very practical side as well. The Harman and Todd Welty version of multi-subwoofer or the multi-sub optimizer software, they're working on the principle, the basic idea of you're not eliminating the room modes, you're actually creating as many of them as you can, and then relying on the idea that they're arriving at your ears at different times, so it all just kind of averages out. You're like activating, this is right in Harman's own white paper, the idea of activating all of the room modes intentionally, but doing so from different locations in the room and using those sort of mathematical timings so that wherever you're sitting, you get this averaging of the room modes where you're sitting. Waveforming is philosophically different from that. They are attempting to cancel out the room modes. They are not attempting to average them across all the seats. They're attempting to eliminate them as best as you can. So that is a like fundamental difference between what's going on here, what their calculations are trying to do versus what multi-sub optimizer software is trying to do. So that is a genuinely different take on it, and supposedly leads to this even tighter time alignment. Yeah.
And you're talking about so the ringing in the room is the big thing that that
Dave
they are
really
kind of
focused
pushing,
on.
that Dave was really focusing on as being, the big benefit you get kind of no matter what.
Right.
But then having a 1 to 2 dB variation from seat to seat to space,
right.
as long as you're at least 3 feet into the room, basically a meter in is what he said, is pretty impressive, but you're still going to end up with people who are going to shove a couch against a wall,
of course,
and wonder why it doesn't work. So there's going to be always some pushback from people who are going to be disingenuous or have done it incorrectly and then blame the product for being faulty. But this is an interesting technology, and the question that we did not ask, and I don't think that they would have an answer anyways. Trinnov is a company that does makes their own devices, puts everything in it, and then it's good to go. And the Trinnov processor is a lot more powerful than your traditional AV receiver. So
it's a full computer in there. It's an absolute full-on PC.
So a waveforming, could this be third-party licensed at some point in the future? They're probably not even close to thinking about that sort of stuff. And plus, there's technological stuff that they would have to overcome, or they would have to dumb down the system to a certain point where it could be run on a less powerful processor, an AV receiver with chips in it that just aren't as powerful because they can't afford to put that much power into one of these things. But could you see a waveforming, upgrade
system on
to
chip at some point?
Yeah, like maybe on a chip. Yeah, exactly. Or in your highest end AV receivers from Denon and Rant and Yamaha.
I think that was definitely way down the line, if ever.
If ever, right? But that's I have been saying for a long time, we need some more competition, because Odyssey and Drac are, and even to a great extent, a Wipeout, they're just not different enough anymore. They are all sounding basically the same. They can only do so much. And this maybe is that push that the industry needs to say, oh, we can do more. And this is how it can be done. And now that they've done it, maybe these other I would hope that these other companies are now scrambling, saying, okay, we need to compete. Because it may not be that they are direct competitors with Trinnov because of the price delta between them, but there's still going to be consumers who are going to be like, wait a second, this is out there. How come you're not?
For anybody who is
like that?
On the borderline and wondering, this is the differentiator. So
there it is.
I appreciate that. I appreciate the dedication to research and development that Trinnov shows, because as Dave pointed out, it's like, they aren't just a group of guys who got together and like, let's maximize profit at the expense of everything else. It's like, no, they're into this for the science of it, for the research of it. I think for a lot of their own edification in the case of the founders, it's like this is what they're into. So I appreciate that very much as an enthusiast myself.
Yeah. All right, so I don't remember what email address he gave at the end of it, so hopefully you guys wrote that down. I don't remember what it was.
It's a week later. We don't have it in front of us. Before we do anything else, though, I did want to send a thanks to the folks over at Caster Communications, the PR firm that is representing Trinnov. That's Pete and Rachel who are taking care of this. We haven't been doing very many interviews here on AVRant for quite a while, and that is all schedule and time-related stuff, but Pete quite literally did this while setting up for his wedding and honeymoon, and we're like, I can't really say no. So want to give a big thanks to them, and a huge thanks to Dave, who was exceedingly generous with his time and reported back that he had a good time talking with us too. So we hope it was excellent feelings all around, because like
we're
I say,
delightful. Let's be honest, Rob.
Really pleased about all of this.
we are a delightful group of a couple of guys to talk to.
No negativity ever around here.
Never. We're so positive about things. All right. This is still AVRant, and we will answer your home theater and AV questions. Send them to question@avrant.com. If you have recommendations for an interview or connections with somebody, we don't always say yes. I'm to be honest with you.
Yeah, I can't make promises. Not out of like lack of interest. It is purely all lack of time around these parts.
I got 3 kids, 2 in college. I'm trying to get them out. 2 of them I'm trying to get out of the house right now, and a lot of stuff going on around here. So it was very hard to schedule this in, but we did get it done.
Yeah,
I'm happy we did.
Yes, we did.
It was a very fascinating conversation. Very excited about waveforming, and to see what happens with the technology and how well it's actually working once people get it into their systems. And the fact that you don't have to buy it if you already have a Trinnov is pretty freaking
That's pretty
cool.
awesome. Like that, this is no small amount of work that went into this. So for them to be like, you know, hey, you already bought an Altitude? You get this thing.
You get it.
Try it if you want to. Ignore it if you want to. Doesn't matter, but it's there for you at no extra cost. So yeah, that's pretty hard to beat.
I'll be honest with you. I've never really felt the need or desire for a Trinnov because I didn't think that there was any super big benefit for me as somebody who has a
Since you're not
room.
doing a channel count beyond 11 speakers. Yeah.
Yeah. But now I'm kind of got a little bit of that FOMO. I might have a bit of FOMO. I might. And if you guys are listening to this podcast, I bet you're thinking the same thing. So,
yeah, there's going to be some of that. We're responsible
save up those
now.
pennies. All right. Send your questions to question@avrant.com.
That is right.
Thank you for listening. And for AVRant, I'm Tom Andrew.
And I'm Rob H. Now go out and listen to something.
Want your question answered? Send it to question@avrant.com. This is AVRant.
Now go out and listen to something.